A tomography reconstructs a 3D volume without destroying specimens. Tomography is increasingly used for geometric inspections and shape analysis. In order to perform 3D inspections, the volume model of the tomography needs to be transferred into a surface representation, a mesh for example. In the past, to generate a surface mesh out of the volume data in GOM Inspect, third-party tools were needed. This step can now be performed directly within GOM Inspect. The workflow is faster and more efficient because you can do everything in one package. GOM Inspect is free to use and avoids using third-party software. GOM Inspect supports volume data formats from different systems. It is even possible to import raw files without an additional configuration file. The software allows the import of various different materials from the scan object as separate surface meshes. How can a mesh be created out of volume data? The 3D volume reconstruction is based on several hundred 2D projection images. The projection images are generated by X-rays while the object is rotating. X-rays penetrate solid objects to create individual cross-sections. The resulting images provide density information about the specimen. The density information from different viewing directions need to be combined to compute the 3D volume. The volume is usually represented as a regular grid of density cells in a 3D space. One cell equals one voxel. To transfer the volume representation into a surface mesh, GOM Inspect does not use a user-defined setting for the surface precision. The software automatically generates a surface representation as precise as possible. To import volume data in GOM Inspect, go to File, Import, File, or you can use drag and drop. You can choose between an automatic or a user-defined import. In the automatic mode, the software assumes that the scanned object consists of only one material. The software imports the meshes as actual meshes. If your object consists of different materials like this bottle top, you should import the volume data with a user-defined setting. The thumbnail shows cross-sections of the specimen and displays a preview of the look of the imported data. The material is presented in red, air in black. You can view the contour of the object and flip through the sectional plane step by step by using the press left mouse button. You can also change the viewing direction along the axes. The histogram shows the gray value distribution of the volume data. Peaks indicate new materials. The black square marks the background. The red square represents material. You can add more materials. The second material is selected automatically and is shown in green. You can change the material selection in the histogram and see a preview of your changes on the left. Using the icon, you can automatically estimate material values. Here you can delete a material. Different materials are displayed as separate surface meshes. You can easily delete areas you do not need for the inspection. Just select the patch you would like to inspect, invert the selection, and delete the selected 3D area.